November 12th, 1942, Richmond, California. A colossal 10,000-ton cargo ship, the SS Robert E. Peary, stood ready to meet the waters of San Francisco Bay. This ship hadn't taken the standard 230 days to build. It had been assembled from keel to launch in an unbelievable 4 days and 15 hours by a workforce of former farmers and housewives. This moment was the stunning culmination of the story that answers an incredible question: how one civilian's impossible trick made the production of the Liberty ships fleet faster than anyone thought humanly possible. It was a revolution sparked by a man who had never built a ship in his life. On December 27th of that year, a man named Henry J. Kaiser signed his first shipbuilding contract. This event, on its own, was hardly newsworthy, but the context was staggering. Kaiser was a man who had never built a ship. He had never managed a shipyard. His entire career had been spent in the rugged American West, moving mountains of earth and pouring rivers of concrete to erect colossal dams like the Hoover and Grand Coulee. He was a master of grand-scale construction, but the delicate, ancient craft of shipbuilding was a world entirely alien to him. And yet, here stood this 58-year-old construction magnate promising the United States Maritime Commission that he would deliver 30 massive cargo vessels for the beleaguered British government within 2 years. To the established shipbuilding community, this was not just ambitious, it was laughable. The traditional shipbuilders, men whose families had been crafting vessels for generations, dismissed him as a naive opportunist, an outsider who had no concept of the complexities involved. The Todd Bath Iron Works, one of America's oldest and most respected shipyards, reluctantly agreed to partner with Kaiser on the project. But they did so with a deep-seated condescension, assuming their centuries of expertise would have to compensate for Kaiser's profound ignorance. What none of them understood, what they could not understand, was that Kaiser's complete lack of shipbuilding experience was not a liability. It was, in fact, his single greatest advantage. He wasn't burdened by the weight of tradition. His mind wasn't cluttered with the rigid, unwritten rules of how things are done. He looked at a ship not as a handcrafted masterpiece, but as a manufacturing problem to be solved with brutal efficiency. Among those watching this audacious gamble unfold was William Francis Gibbs, America's most respected naval architect. His firm, Gibbs and Cox, had created the very plans for the Liberty ship, based on a British design. Gibbs had designed more ships than Kaiser had likely ever seen in his life, and he, like the rest of the maritime establishment, watched with a mixture of professional curiosity and profound skepticism. The journey from skepticism to full-blown revolution began in the planning offices of Todd Shipyards in New York City. As Kaiser and his team of engineers, men accustomed to thinking in terms of cubic yards of concrete and miles of highway, examined the traditional shipbuilding procedures in early 1941, they had an immediate and startling realization. The conventional methods were simply too slow. The ancient revered process of building a ship piece by piece from the keel up was a relic of a bygone era. It would never, ever meet the voracious demands of a world at war. The real spark of genius came from Kaiser's chief engineer, a man named Clay Bedford. Just weeks before, Bedford had visited a Ford Motor Company assembly line in Detroit. He had stood mesmerized, watching automobile chassis move steadily down a production line as workers, each with a specific task, installed prefabricated components at their designated stations. It was a symphony of standardized, repeatable actions, a miracle of mass production. Bedford returned to California with a conviction that burned in his mind. Ships could be built the same way. When he proposed this to the traditional shipbuilders, they considered the comparison absurd, even insulting. A car was a simple, standardized machine. A 10,000-ton cargo ship was a complex, bespoke vessel, a floating city that had to withstand the fury of the North Atlantic. The two were worlds apart. The first real shock to the system came with Kaiser's proposal to completely eliminate riveting. For centuries, ship construction relied on rivets. These were heated metal pins, glowing cherry red, that were hammered through overlapping steel plates by a coordinated team of men to join them together. It was skilled, dangerous, and incredibly time-consuming work. A top-tier riveting crew, working in perfect sync, might install 100 rivets on a good day. Each Liberty ship, if built conventionally, required approximately 1 million rivets. The math was grim and unyielding. Kaiser proposed a radical alternative: electric arc welding. It was a technique he had mastered during his years building massive pipelines across the American West, a method that was faster, stronger, and required far less specialized skill. Vice Admiral Emory Land, the formidable chairman of the United States Maritime Commission, examined Kaiser's proposal with deep, ingrained skepticism. His private correspondence from the time, now preserved in the National Archives, reveals the maritime establishment's horrified reaction. One memo read, "Welding has never been proven reliable for hull construction at this scale. The British Navy forbids welding on warship hulls. Kaiser is proposing we bet America's supply lines on an unproven technology." It seemed like a reckless, irresponsible gamble. Yet Land also recognized the crushing weight of desperation. German U-boats and surface raiders were conducting a merciless campaign in the Atlantic, sinking Allied shipping far faster than traditional shipyards could ever hope to replace the losses. In 1941 alone, a staggering 3.6 million tons of Allied shipping would be sent to the ocean floor. Great Britain, an island nation, was literally starving, its lifelines being systematically severed. American shipyards, using their time-honored conventional methods, required an average of 230 agonizing days to build a single cargo ship. At that glacial pace, the Allies would lose the crucial battle of the Atlantic long before American industry could ever make a meaningful difference. The decision to approve Kaiser's contract was not born of confidence in his methods. It was an act of sheer, unadulterated necessity. They had no other choice. It was the dam builder's wild gamble, or it was defeat. The Richmond shipyard, the first of Kaiser's West Coast operations, rose from empty mudflats with breathtaking speed between January and December of 1941. Kaiser's construction crews, the same men who had conquered rivers and mountains, erected a facility that horrified traditional maritime engineers. Established shipyards were characterized by massive gantry cranes and long, longitudinal building ways where a ship was painstakingly constructed in one spot. Richmond, however, looked utterly different. It was laid out not like a shipyard, but like the automobile assembly plant that had so inspired Clay Bedford. Vast open areas for prefabrication surrounded 7 parallel building ways. A complex web of railroad tracks crisscrossed the facility, designed to move massive pre-assembled steel sections weighing up to 150 tons. Towering overhead cranes, with a lifting capacity that seemed absurdly excessive, stood every 100 feet, ready to hoist entire sections of a ship into place like giant building blocks. John Riley, the chief naval architect for Bethlehem Steel Corporation and a 30-year veteran of shipbuilding, visited the Richmond Yard in May 1941. His confidential inspection report captured the establishment's mix of technical criticism and grudging, bewildered admiration. He wrote, "Kaiser has violated every principle of efficient shipyard layout I have learned in 3 decades of experience. His prefabrication areas are too large. His crane capacity is absurdly excessive. His building ways are too short. Yet, I must admit, the facility is designed for exactly what he claims: the rapid assembly of prefabricated sections." The old guard was beginning to realize that Kaiser wasn't just building ships, he was building a new way of thinking. And the next phase of his revolution would be even more shocking: the people he hired to do the work. He would build his armada not with craftsmen, but with an army of amateurs who would rewrite the rules of labor itself. The arrival of the workers at Kaiser's new shipyards marked the next phase of his revolutionary transformation. Traditional shipyards were closed communities, recruiting their labor from established maritime towns where specialized skills were passed down from father to son, generation after generation. It was a guild system, a closed loop of inherited expertise. Kaiser blew that system wide open. He advertised in newspapers across America. From the farmlands of the Midwest to the cities of the South. He offered wages a full 20% above standard industrial rates, a powerful lure in a nation still recovering from the Great Depression. And he made a promise that seemed almost too good to be true. He would train anyone willing to work, regardless of their background or experience. The first waves of these new workers began arriving in Richmond in August 1941. They were not shipwrights. They were former secretaries, farmers, housewives, beauticians, and laborers. They were a cross-section of America, united by a desire for a steady paycheck and a patriotic duty to contribute to the war effort. To the traditionalists, this was madness. How could you build a complex, ocean-going vessel with people who had never even seen a shipyard before? Kaiser's genius was in recognizing that you didn't need to teach one person 1,000 complex skills. You just needed to teach 1,000 people one simple skill each. The simplification of complex tasks into repeated simple operations, a principle borrowed directly from Henry Ford's assembly lines, proved to be devastatingly effective. Traditional welders spent 4 years as apprentices, slowly learning a comprehensive set of skills. Kaiser's instructors, by contrast, taught specific welding techniques for specific tasks in approximately 2 weeks. A worker didn't need to know how to weld everything. They only needed to master the art of welding the vertical seams on bulkheads, or the horizontal deck plates, or the curved hull sections, a task they would then perform over and over again, hundreds of times, until they could do it with speed and precision in their sleep. By October 1941, Kaiser employed over 10,000 workers in Richmond alone. Of that massive workforce, fewer than 200 had any previous maritime experience. It was an army of amateurs, and they were about to shock the world. As these newly minted welders and fitters gained experience through the final months of 1941 and into early 1942, something extraordinary and completely unexpected began to occur. The construction time for Liberty ships began to fall, not gradually, but dramatically. The statistics tell a stunning story of progress. Kaiser's very first Liberty ship, the SS Patrick Henry, took a respectable 197 days to build and deliver, still significantly faster than the 230-day average. But that was just the beginning. Ship number 2 required 169 days. Ship number 5 took 128 days. Ship number 10 was completed in just 97 days. By the spring of 1942, the Richmond yard was completing and delivering Liberty ships in an average of 70 days. The traditional shipyards watched with a mixture of disbelief and growing alarm as this untrained workforce, this collection of amateurs, achieved production speeds that now matched and were beginning to surpass their own highly skilled generational crews. The power of the prefabrication approach, which the traditional builders had so readily dismissed as impractical, was now proving its overwhelming superiority. Instead of building a ship from the keel up in a linear sequence on the building way, Kaiser's yards fabricated entire sections simultaneously, in parallel, all across the sprawling facility. While one crew was assembling a massive bow section in a dedicated prefabrication area, other crews were simultaneously building the stern sections, the deck houses, the engine rooms, and the interior bulkheads. It was a massive, coordinated dance of industrial production. When the individual sections were complete, the towering cranes, the ones the experts had called absurdly excessive, would lift the multi-ton modules onto the building ways, where armies of welders would join them together. Albert Wooding, a production supervisor at Richmond Yard No. 2, explained the elegant efficiency of the system in 1943 interview with Fortune magazine. In traditional shipbuilding, he said, you cannot install the engine until the engine room is built. You cannot build the engine room until the hull is complete. Everything happens in sequence. Kaiser's approach allows parallel production. While one crew welds hull plates, another crew assembles the engine in a separate area. When both are ready, we drop the completed engine into the completed engine room and weld it in place. Tasks that previously required weeks of painstaking work now take mere hours. The raw statistics of this parallel production revealed a level of manufacturing efficiency that seemed impossible to the traditional builders. In a conventional shipyard, a team of perhaps 50 workers might struggle for 3 weeks to install an engine, working in the cramped, dark, and dangerous confines of a partially completed engine room. At Kaiser's yard, a team of 200 workers would assemble the complete engine and its massive mounting structure in a spacious, well-lit open workshop over just 5 days. Then, the giant cranes would lift the entire assembly and position it perfectly in a single 8-hour operation. It was a monumental shift in both time and labor. Even more disturbing to the traditional maritime authorities was Kaiser's casual elimination of other centuries-old shipbuilding practices. Ships had always been built from meticulously detailed, carefully drafted plans that specified every single rivet, every single plate, every single detail. It was a process that required precision and adherence to a master blueprint. Kaiser, however, used radically simplified drawings that provided only the basic dimensions and left many of the smaller details to the workers' and foremen's judgment on the floor. To the traditional builders, this was pure recklessness, an invitation to disaster. Kaiser simply called it flexibility, trusting his workers to solve problems on the fly. Vice Admiral Howard Vickery, the vice chairman of the Maritime Commission and a career naval officer, initially fought tooth and nail against Kaiser's simplified specifications. His remarkable transformation from a staunch skeptic to a fervent supporter, documented in the Commission's meeting minutes, perfectly illustrates the overwhelming power of results over theory. In a meeting in January 1942, Vickery stated, "I opposed Kaiser's request to reduce drawing specifications. Ships are not automobiles. Maritime construction requires precision." But his tone had changed dramatically by the summer. By March, he later admitted, Kaiser's yards were outproducing our traditional contractors by 40%. By June, the gap had widened to 70%. I learned that perfection is the enemy of sufficient. Kaiser's ships were not beautiful. They were adequate. And adequate ships delivered more cargo than perfect ships that were still under construction. As the construction speeds continued to accelerate through the spring and summer of 1942, a new, powerful dynamic emerged: competition. An intense but friendly rivalry developed among Kaiser's 7 shipyards, which were spread across California, Oregon, and Washington. His own son, Edgar Kaiser, served as vice president and general manager, overseeing all the shipyards with a particular focus on the 3 facilities in the Pacific Northwest, including the Oregon Shipbuilding Corporation in Portland. Meanwhile, the formidable Clay Bedford oversaw the Richmond yards in California. The 2 men, both fiercely driven and ambitious, began an informal contest to see whose facility could build ships faster. This race between Richmond and Portland became a public spectacle through the fall of 1942. Newspapers published daily updates, treating the production numbers like sports scores. The competition spurred incredible innovation and effort, with records falling repeatedly. The contest reached a fever pitch in September 1942, when the Oregon Shipbuilding Yard built the SS Joseph N. Teal from keel laying to launch in an astonishing 10 days. Vice Admiral Vickery, concerned that these record-breaking stunts were distracting from the overall production goals of the war effort, eventually ordered the speed competition to be stopped. But the competition had already served Kaiser's purpose perfectly. The workers across all 7 of his yards now believed that this extraordinary speed was not merely possible, but that it was expected. They had seen the impossible become reality with their own eyes. The psychological barrier had been shattered forever, and that set the stage for the ultimate demonstration, a feat so incredible it would silence the critics once and for all and echo through the annals of industrial history. A challenge was about to be laid down, one that would aim to build a ship not in 10 days, but in less than 5. The final definitive demonstration of Kaiser's revolutionary method was sparked by a casual, almost offhand comment. In November 1942, Vice Admiral Land was visiting the Richmond yards to inspect production. Speaking to a group of journalists, he remarked that Liberty ship construction had improved remarkably, but he noted that the recent 10-day speed record, while impressive, still paled in comparison to what true mass production had achieved in other industries, like automobile manufacturing. That comment was overheard by Clay Bedford. To a man as proud and driven as Bedford, this was not a simple observation. It was a challenge. He approached Vice Admiral Land and made an audacious proposal. Richmond Yard Number 2 would attempt to build a complete Liberty ship from the moment the keel was laid to the moment it was launched in under 5 days, effectively cutting the incredible record of the Joseph N. Teal in half. Land, though still deeply skeptical, was also intrigued. He authorized the attempt, but with one firm condition: it could not disrupt the regular production schedules of the other ships. Bedford selected the 47th hull to be built at Yard Number 2 for this record-breaking attempt. The ship would be named the SS Robert E. Peary in honor of the famed Arctic explorer. The clock would start on Sunday, November 8th at 1 minute past midnight. For the next several days, over 1,000 workers, operating in 3 perfectly coordinated shifts around the clock, would attempt something that had never been done before in the entire history of maritime construction. The prefabrication strategy reached its ultimate, most glorious expression during the construction of the Peary. Every single major component of the ship had been built, inspected, painted, and staged in precise locations around the building way before the keel even touched the blocks. This was the key. The massive bow section, a complex structure comprising more than 50 individual steel pieces, had been fully welded together and was already equipped with its anchor hardware, chain lockers, and even the forward crew quarters. The stern section was similarly complete, with the steering gear, propeller shaft, and aft crew spaces already installed. 4 complete cargo holds, each one a massive rectangular structure of steel, were waiting to be lifted into position. The heart of the ship, a 140-ton triple expansion steam power plant, had been built by the Joshua Hendy Iron Works in nearby Sunnyvale. It had been fully assembled, mounted on its foundation structure, and even test-fired before it left the factory. Where conventional shipyards painstakingly built a ship from the keel to the deck over many months, piece by agonizing piece, Kaiser's yard was about to assemble a nearly complete ship from massive prefabricated modules in a matter of days. The work began with a controlled fury. As the first section of the keel was laid, teams of workers swarmed over it. The process was a symphony of steel and human effort, orchestrated by the constant movement of the towering cranes. Huge sections, weighing as much as 250 tons, were lifted into the air, guided into position by teams on the ground, and then descended into place with millimeter precision. As soon as a section was set, armies of welders descended upon it, their torches spitting arcs of brilliant white light, permanently stitching the steel behemoth together. Just 4 days into the construction, the whole was complete. The engine had been installed, the deck houses were positioned, the cargo holds were secured, and the steering gear was mounted. On Thursday, November 12th, at 3:30 in the afternoon, just 4 days, 15 hours, and 29 minutes after the keel had touched the building way, the SS Robert E. Peary slid gracefully down the launching rails and into the waters of San Francisco Bay. The ship was then towed to an outfitting dock where the final touches were applied. It was fully delivered and ready for service on November 15th, setting an additional, almost equally incredible record: 7 days, 14 hours, and 32 minutes from the moment the keel was laid to full delivery. The crowd of observers who had gathered for the launch was a who's who of the maritime and military world. It included officials from the Maritime Commission, high-ranking military officers, the owners of competing shipyards, and journalists from across America. Many of them had arrived expecting to witness either an embarrassing failure or, at best, a compromised vessel. A ship that looked complete from a distance but was little more than a hollow shell, lacking the functionality to actually serve. What they saw instead was a fully operational ship that required only minor, routine fitting out before entering active service. Vice Admiral Land, who was present for the momentous launching, gave brief remarks that were captured by newsreel cameras for the entire nation to see. His words were not just praise, they were a public capitulation, a forced recognition from the very top of the maritime establishment that everything they knew everything they believed had just been proven wrong. 6 months ago, Land admitted, his voice heavy with the weight of the moment, I would have called this impossible. Traditional shipbuilding wisdom, accumulated over 3,000 years, said you cannot build a proper ship in 5 days. Henry Kaiser has made traditional wisdom obsolete. The United States Maritime Commission will now require all contracted shipyards to adopt these methods. The psychological impact on the traditional shipbuilders was profound and immediate. The very same yards that had dismissed Kaiser as an ignorant outsider just 18 months earlier were now dispatching their top engineers to his facilities, desperate to study his revolutionary approaches. The president of the New York Shipbuilding Corporation, one of America's oldest and most prestigious yards, visited Richmond in December 1942. His confidential report to his board of directors revealed a complete ideological collapse regarding their traditional, centuries-old approaches. He wrote, Kaiser has achieved what our industry considered impossible by refusing to accept our limitations. He treated shipbuilding as a manufacturing problem rather than a craft tradition. He simplified where we sought perfection. He standardized where we customized. He trained masses of unskilled workers where we cultivated generational expertise. The result is ships built in 1/10 the time at 2/3 the cost. We must either adopt his approaches or accept our own irrelevance. By early 1943, Kaiser's influence had utterly transformed the landscape of American maritime production. 18 shipyards across the country were now building Liberty ships using his methods of prefabrication and welding. The average construction time for a Liberty ship had plummeted from the initial 230 days down to just 42 days by the middle of 1943. The United States was now launching, on average, 3 Liberty ships every single day, a volume of new tonnage that was finally beginning to outpace what the German submarines could sink. But perhaps the most devastating challenge to the traditional maritime authority came not from the speed of construction, but from the quality and character of Kaiser's workforce. The tens of thousands of women, minorities, and previously untrained workers who had built these ships represented a direct, undeniable repudiation of the old exclusionary guild system that had dominated shipbuilding for centuries. At peak production in 1944, Kaiser's 7 yards employed approximately 196,000 workers. Of these, over 40,000 were women, a remarkable and groundbreaking percentage for female industrial workers at the time. By mid-1944, women comprised a full 27% of Richmond's production workforce. The 3 Kaiser yards in the Northwest alone employed over 31,000 women. African American workers, who had been systematically excluded from skilled trades, numbered in the tens of thousands. They were employed in skilled positions, including welding, fitting, crane operation, and even held supervisory roles, a level of workplace integration that was highly unusual for 1940s America. This democratization of skilled work that Kaiser's system enabled carried profound implications that reached far beyond the immediate needs of wartime production. By proving that complex manufacturing could be performed by ordinary people who were properly trained, rather than requiring generational craft expertise, Kaiser's shipyards challenged the fundamental, long-held assumptions about labor, skill, and industrial organization. He had not only built a ship in 4 days, he had built a new model for the American workforce. This new model would not only win the war, but would also leave an indelible mark on the nation's social and economic fabric for decades to come. The revolution sparked by Henry Kaiser was not confined to industrial processes. It was a social revolution as well. The Christmas of 1943 provided another powerful demonstration of Kaiser's transformed industrial culture. While traditional shipyards observed the holiday with 1 or 2 days off, Kaiser's facilities maintained their relentless, around-the-clock production schedules. But rather than simply demanding that his employees work through the holiday, Kaiser's organization made a point of providing Christmas celebrations that acknowledged and honored the workers' immense sacrifices. At the Richmond yards, the management arranged for a full Christmas dinner to be served in the facility cafeterias, complete with turkey, ham, and all the traditional accompaniments, provided free of charge to every worker on shift. Local churches sent choirs to sing carols that echoed through the cavernous steel halls. The Richmond Municipal Band performed, its cheerful music a stark contrast to the clang of hammers and the hiss of welding torches. Kaiser himself visited the yards, a tradition he maintained throughout the war, walking through the facility, shaking hands with workers, and personally thanking them for their service. This was more than just a morale booster. It was a reflection of a new philosophy that saw workers not as cogs in a machine, but as vital partners in a shared, patriotic enterprise. By the middle of 1944, Kaiser's 7 shipyards had produced over 800 Liberty ships. But the influence of his approaches had spread far beyond his own facilities. The 18 American shipyards that were building Liberty ships had, collectively, produced an astonishing 2,400 vessels by this point. A new class of vessel, the Victory ship, a larger and faster design that supplemented Liberty production from 1944 onward, was also being built using the same revolutionary prefabrication and welding techniques. The total American maritime production between 1941 and 1945 was a figure that staggered contemporary observers and remains impressive even by modern standards. It exceeded 5,500 vessels, representing approximately 53 million tons of new shipping. This bridge of ships across the Atlantic and Pacific was the logistical backbone of the entire Allied war effort. Commander Joseph Kenworthy of the Royal Navy, who was assigned to the British Admiralty delegation in Washington, watched this explosion of American production with a mixture of admiration and professional envy. His official reports back to the Admiralty, which were declassified in the 1980s, capture the British perspective on America's newfound industrial dominance. The United States is building merchant shipping at a rate that exceeds the combined capacity of the rest of the world, he wrote. Kaiser alone produces more tonnage monthly than the entire British shipbuilding industry. The approaches are crude by Admiralty standards. The ships are inelegant, but they float, they carry cargo, and there are thousands of them. The Royal Navy builds the finest warships in the world using traditional craftsmanship, requiring years per vessel. The Americans build adequate ships in weeks. Adequate, multiplied by thousands, defeats perfection, multiplied by dozens. But perhaps the most remarkable aspect of Kaiser's transformation was what happened after the war ended. Traditional analysts had fully expected the wartime shipbuilding boom to collapse, leaving tens of thousands of workers unemployed and hundreds of costly specialized facilities abandoned and rusting. This prediction proved to be only partly true. Liberty ship production officially ended in September 1945. By December, Kaiser's massive workforce had fallen from its peak of nearly 200,000 to fewer than 20,000. The Richmond shipyards, which had employed 100,000 workers at their peak, stood largely empty and silent by the spring of 1946. Yet, the knowledge, the process that had been developed during this emergency program did not disappear. The prefabrication techniques, the advanced welding procedures, and the parallel assembly approaches that Kaiser had pioneered became the new standard practice in global shipbuilding. When Japan and South Korea, nations devastated by the war, began to rebuild their maritime industries in the 1950s and 60s, they didn't look to the old traditions of Europe. They studied Kaiser's Liberty ship program. They adopted his revolutionary approaches as the very foundation of their new modern yards. The massive shipbuilding facilities in Ulsan, South Korea, and Nagasaki, Japan, yards that would come to dominate world shipping construction for decades, were the direct industrial descendants of the revolutionary practices born in the mudflats of Richmond, California. John Bunker, a professor of maritime history at the State University of New York Maritime College, summarized Kaiser's lasting and profound influence in his definitive study, published in 1972. Kaiser entered shipbuilding as an outsider, ignorant of maritime tradition, unconstrained by conventional wisdom, and willing to apply manufacturing principles that the established industry considered inappropriate for ship construction, Bunker wrote. In 36 months, he built more ships than had been constructed in America during the entire previous century. More importantly, he fundamentally altered how ships would be built worldwide for the remainder of the 20th century. The modular construction, prefabrication, and welded assembly that Kaiser pioneered are now universal standards. Every modern shipyard, whether building container vessels in Korea, oil tankers in Japan, or cruise ships in Europe, uses approaches derived directly from Kaiser's Liberty Ship program. The sheer magnitude of Kaiser's achievement can be measured in a set of statistics that reveal both the incredible scale of the program and its remarkable, undeniable success. Production statistics show that a total of 2,710 Liberty ships were built across 18 American yards between 1941 and 1945. This represents an average of 1.8 ships being launched per day at peak production. Kaiser's 7 yards alone produced 1,490 of these ships, comprising a full 27% of the total American wartime merchant shipping built under the Maritime Commission contracts. The improvements in labor efficiency were just as dramatic. The first Liberty ships required approximately 1.1 million worker hours to complete. By 1943, the average number of worker hours had fallen to approximately 486,000 per ship. Kaiser's most efficient yards, Richmond numbers 2 and 3, were able to achieve construction in as few as 350,000 worker hours by maximizing prefabrication and utilizing 3-shift, 24-hour production schedules. This efficiency also translated to cost. The first Liberty ships cost between $1.75 and $2 million each. By 1943, despite rising wages and material prices, the cost had fallen to $1.8 million, a clear reflection of the improved efficiency and the steep learning curve effects. Each of these adequate ships could carry an immense amount of cargo, 10,800 tons to be precise. In a single voyage, a Liberty ship could transport 2,840 jeeps, 440 tanks, or an incredible 130 million rounds of ammunition. They were powered by triple expansion steam engines that were deliberately old-fashioned but were reliable and, crucially, easy to manufacture in massive quantities. This allowed them to achieve speeds of 11 knots, which was adequate for convoy operations. The training efficiency proved to be equally remarkable. Kaiser's schools trained workers in specific specialized tasks in an average of just 2 weeks. The fastest training programs could produce productive spot welders in only 10 days. More complex positions, like crane operators or shipfitters, required 4 to 6 weeks of training. This stands in stark contrast to the traditional maritime apprenticeships, which lasted 4 years for basic competency and a full 10 years to achieve master craftsman status. The key difference was specialization versus comprehensive training. Traditional apprentices learned all aspects of shipbuilding. Kaiser's workers, on the other hand, mastered specific, repeatable tasks that they would then perform hundreds of times, achieving an incredible level of proficiency through sheer repetition. The ultimate proof of the program's success, however, came from the performance of the ships themselves. Of the 2,710 Liberty ships built, approximately 200 were lost to enemy action, a loss rate of 7.4%. This compared favorably with pre-war merchant shipping loss rates and proved, once and for all, that welded construction, while initially suspect, produced tough, seaworthy vessels capable of withstanding the rigors of wartime service. But the legacy of these ships would extend far beyond the war, proving their durability and influencing industries in ways Kaiser himself could never have imagined. While the Liberty Ship program was an overwhelming success, it was not without its problems. The rapid adoption of a relatively new technology like welding on such a massive scale inevitably led to some failures. A number of the ships experienced significant structural failures due to welding defects and issues with the steel used, which could become brittle in the cold waters of the North Atlantic. In the most dramatic cases, 3 Liberty ships broke completely in half due to these brittle fracture problems. While this represented a tiny fraction of the total production, just 0.11%, it was a serious issue. Nearly 1,500 instances of significant, though not catastrophic, brittle fractures occurred across the Liberty fleet. These failures, however, led to crucial research and resulted in improved welding procedures and higher quality steel specifications that effectively eliminated the problem by 1944. In a way, even these failures contributed to the advancement of industrial knowledge. The ultimate vindication of Kaiser's construction approaches, however, came from the remarkable longevity of the ships. These vessels were designed as emergency ships with an expected service life of only 5 years. They were meant to be expendable, a temporary solution to a wartime crisis. Yet, they proved to be remarkably durable. Many of the Liberty ships remained in active service for decades after the war. The SS John W. Brown, built in 1942, remains fully operational as a museum ship in Baltimore as of 2024, an incredible 82 years after its construction. The SS Jeremiah O'Brien, also built in 1942 and now preserved in San Francisco, achieved a particularly stunning feat. In 1994, it participated in the 50th anniversary commemoration of D-Day by actually sailing to Normandy under its own power. A 50-year-old emergency vessel crossing the Atlantic once more. A third Liberty ship, the SS Hellas Liberty, serves as a static museum ship in Greece. The post-war careers of the Liberty ships extended far beyond their designed lifespan. Of the approximately 2,510 Liberty ships that survived the war, around 835 remained in active commercial service through the 1960s. Many were sold to foreign shipping companies, where they continued to operate into the 1970s, becoming a familiar sight in ports all around the world. The SS Albert M. Bow, the very last Liberty ship built and delivered on October 30th, 1945, was never scrapped. It was sold in 1964 for $65,557 and was converted into a fish cannery ship, the Star of Kodiak. Today, it remains as the landlocked headquarters of Trident Seafoods in Kodiak, Alaska, a permanent land-based monument to its own durability, still in existence 8 decades after its construction. Kaiser's methods were revolutionary, but they also created temporary boom towns that vanished after the war, disrupting countless lives. Was this rapid, disposable approach to industry a necessary wartime miracle or a troubling precedent for the future? Let us know your thoughts below, and don't forget to like and subscribe.